Another way where this process becomes useful is when we're trying to maximize an area. We might be in a confined area, but we want to maximize its internal area by adjusting its length and height, or its length and width. So let's say, for example, I have a footprint to a house, and I'm able to build on, but I have some restrictions on how much I can build on. I want to build on 15 additional square meters, maybe extend my bedroom out. And the restrictions I have is that my length has to be 7 meters less than the width has to be 7 meters less than 2 times the length. And that's probably who our city building code enforcers kind of let us know that, given your property, those are some of the restrictions you have. So for this example, that was the restriction we'll use. So the first thing I need to do is, well, I need to know what these dimensions are going to be. So step one is, let's identify our variable. What is it that you know the least amount about? Do you know more about its length or more about its width? Well, we know nothing about its length, but we know its width in terms of its length. Its width is 7 meters less than 2 times its length. 7 meters less than 2 times that length. So I was able to write the other unknown in terms of the former unknown. Now what I have is that I have the basic dimensions of this space. And I know that its area has to equal 15. What do we remember about finding the area of a rectangular space? Its length times width. So I have its length is x, its width is 2x minus 7, and that equals a total of 15 square meters. Kind of looks like maybe we can get a quadratic out of this. So let's rewrite this in standard form. That's 2x squared minus 7x equals 15. Subtract 15 from both sides. Equals 0. Let's trial and error this. Two x and x, factors of 15 that make a 7 with everything else, 5 and 3. 5 and a 3. I have to have a negative 7x, so that's going to be a negative 5 and a positive 3. All right, through some trial and error, I found its factors. Let's set each factor equal to 0. 2x plus 3 equals 0. 2x equals a negative 3. X equals a negative 3 halves. X minus 5 equals 0. And x equals 5. There's my two apparent solutions. But since we are modeling something we demonstrate or we understand in the real world, and we're looking at what are my values of x, they have to be a positive length. And so given that the case, I can rule that solution out and that solution in. So now I have enough information to discover that my length has to be 5. It's kind of my check. And over here, 2 times x minus 7 produces a 3. So I'm able to add on to my existing structure with a 5 by 3 addition, 5 foot by 3 foot, or meter, 5 meter by 3 meter addition. And that gives me my additional 15 square meters of room.